Shall we start
Hello
now?
everyone. So welcome to
Hello.
today's session. Hello sir. Okay. Shall we start the session? Yes, of course. Today we are going to do some sums in complex numbers, right? Right. Okay. The first sum today we are going to solve is determine the locus of z such that real value of z minus 4 divided by z minus 2i equals 0. Okay, so here is the question, right? Right. What they given? They given that real part of z minus 4 divided by z minus 2i equals to 0. What they ask us to find? They ask us to find the locus of z. Right. Whenever we solve the sum, we have to write the given first. What they given? Given real part of z minus 4 divided by z minus 2i equals 0. Right? What we are going to find here? We are going to find here is locus of z. Right? Shall we start? Yes. Here comes our solution. To find the locus, I have to take z equal to x plus I y. Right? Right. Z is a complex number, so it will contain a real part and an imaginary part. Right? Right. So I am going to substitute the x z equals x plus iy in this form, right? So I take z minus 4 divided by z minus 2i. So I am going to replace z with x plus iy, right? Right. So x plus iy minus 4 divided by x plus iy minus 2i. Now I am going to separate the real part and the imaginary part, right? In enumerator, who are the real ones? X minus 4. Who is the imaginary part? Plus iy, right? Likewise, we are going to do in the denominator. Who is the real one? Right? These both are imaginary terms. Right? I am going to take I in both terms as a common term. So x plus, I am going to take this I out. So I into y minus 2, right? Right. Fine. So I will give you 1 minute. Please guys copy this down so that I can wrap it out and start solving this. Okay. I hope you copied this. Shall I wrap it? Yes. What I already had. So x minus 4 plus iy divided by x plus I multiplied by y minus 2, right? This is what I solved. So what was the next step? Next step is, now we are going to eliminate this imaginary part, right? For that, I am going to do a simple multiplication and division. So what I am going to do is, I'm going to multiply and divide by a same term so that the value remains same, right? So that I'm going to multiply by this complex numbers complementary, right? So I'm going to multiply it by x minus I into y minus 2, right? Divided by x minus I multiplied by y minus 2, right? Right. I just multiplied by this number's complement, right? Right. So shall we multiply it? Yes. So x minus 4 plus iy multiplied by x minus I multiplied by y minus 2, right? Now see the denominators. In which form it lies? Consider the old excess a and the old term I multiplied by y minus 2 as b. So this one lies in a plus b and this one lies in a minus b. What we are going to do here? We are going to do multiplication here. So what is the formula for a plus b multiplied by a minus b? Equals a squared minus b squared, right? Right. We are going to apply the same here in the denominator. What do you have in here? X. So x whole squared minus a squared minus b squared, right? So what is the entire beta? I multiplied by y minus 2 the whole square, right? Right. Now I'm going to multiply the entire term in between these two things, right? First I'm going to multiply this by x. So x into x minus 4. Then next I'm going to multiply I with iy. So plus I x OT. Then I'm going to multiply this part with the both of them. First, I'm going to multiply minus I x minus 4 multiplied by y minus 2, right? And I'm going to multiply this with this. So minus I into I squared y multiplied by y minus 2, right? Right. What will be the denominator? X squared minus, what is the value? If we square the I, it will be I squared. What is the value of I squared? So I squared, the value will be minus 1. Right? I am going to substitute here. So for I squared, I substitute minus 1. For y minus 2 the whole square, I am going to keep it as y minus 2 the whole square. Right? Right. Okay. I'm also going, now I am going to substitute this I squared with minus 1. Okay. So the value will be x into x minus 4 plus I xy minus I x minus 4 y minus 2. Now we are going to substitute minus 1 in this place. So minus of minus 1 will be plus, right? So plus y multiplied by y minus 2 divided by x squared. Minus of minus 1 will be plus y minus 2 the whole square, right? Right. What I am going to do now is I am going to separate the real part and the imaginary part. Who are the real terms here? X into x minus 4. Fine. Take this. X into x minus 4, right? Then who else is here? Y multiplied by y minus 2. So plus y multiplied by y minus 2, right? These are lies on a real part. Who lies in the imaginary part? These two guys, right? I'm going to take this I as a common. So plus I multiplied by xy minus x minus 4 y minus 2, right? So the denominator will remain the same. X square plus y minus 2 the whole square, right? Okay, guys. Do you have any doubts till now? Okay, fine. So I will give you another half more minute so that you can copy these things down. Okay? Okay, I will wait till you copy these. Okay. I hope you guys copied this. So I'm gonna wrap this down. Shall I? Yes. Okay. So we have two terms, real part and the imaginary part. Both have a common denominator. So I'm going to separate this denominator to this one and to this one, right? Shall we write it down separately? Yes. What we have here? X multiplied by x minus 4 plus y multiplied by y minus 2 divided by what we have? X squared plus y minus 2 the whole square plus, here's the imaginary part, right? So I keep I as a common for both numerator and denominator. So what else we have here? So x minus y minus of x minus 4 multiplied by y minus 2 divided by x squared plus y minus 2 the whole square, right? Right. So what we know that from a question? In the question they already given that real part of z minus 4 divided by z minus 2i equals to 0. Right? Now here we solved it for x minus 4 divided by z minus 2i. So we have this equation. In this, who is the real part? This guy is the real part, right? Here I is there, so it will be an imaginary part. So this part will be equals to 0. So x multiplied by x minus 4 plus y multiplied by y minus 2 divided by x squared plus y minus 2 the whole square equals 0. Right? Because this is what given in a question. Real part of z minus 4 divided by z minus 2i equals 0. So we solve this and we find the real part, we substitute it. Right? Right. Now I am going to take the entire part to this side. So anything multiplied by 0, it remains 0. So x multiplied by x minus 4 plus y multiplied by y minus 2 equals 0. Now I am going to multiply the x inside. So x squared minus 4x plus, now I am going to multiply y within this. So y squared minus 2y equals 0. I am going to rearrange this. X squared plus y squared minus 4x minus 2y equals 0. So now we find the locus, right? Okay. Then we can write it down. Locus of z is x squared plus y squared minus 4x minus 2y is equals 0. That's it, guys. So we solve the first sum, right? Right. I will give you another 1 more minute to copy this down. Do you guys have any doubt in this question? Okay. Okay, guys. I hope you guys written this. So now I'm going to rub this and we are going to solve the another sum. Right? Okay. So what is the next question? Okay. The next question is if the amplitude of z minus 2 divided by z minus 6i is equals to pi by 2, then find its locus. Okay. Last sum they directly given that the real part of a complex number, right? Now they are given that the amplitude value of this complex number equals to pi by 2, right? Right. Shall we solve? Right. They ask us to find the locus. Whatever the question, we are going to write the given first. Given. Amplitude of z minus 2 divided by z minus 6i equals pi by 2. Right. What we are going to find here? We are going to find locus. Right? Clear? Shall we start the solution? Yes. Solution. So for that we are going to take let z equals x plus iy. Right? Then we are going to substitute this x plus iy in this term. So z minus 2 divided by z minus 6i. So in place of z we are going to substitute x plus iy. So x plus iy minus 2 divided by x plus iy minus 6i. Right? As like that of the previous sum, we are going to separate the real part and the imaginary part. Okay? Who is the real guys here? X and minus 2. X minus 2 plus who is imaginary? Iy divided by x is the only imaginary part here. So I keep x there. And now we are going to take this I from both of these terms. So plus I multiplied by y minus 6. Right? Right. So at this point, we are going to do the same thing as like that of a previous one. So what did we done? Yes, of course. So what we done is we multiplied and divided the entire thing by the complement of this complex number, right? Yes. So we are going to multiply and divide this by the complement of the denominator, right? Right. So x here plus, so minus I multiplied by y minus 6 divided by x minus I multiplied by y minus 6. Right? If we multiply and divide the same thing by the same number, the value remains same. Right? Okay, fine. So I will give you 1 more minute so that you can copy this down and we can move to the next step. Right? Right. Okay, guys, I hope that you copied this one. Shall we move to next step? Yes, of course. Okay. Shall we multiply this? Yes. What we have here? X minus 2 plus IY multiplied by X minus I multiplied by Y minus 6. Right? Okay. In the denominator, it was like A plus B multiplied by A minus B. So the output will be A squared minus B squared. So who is in the place of A? X. So X squared minus of who is in the place of a B? The entire term. I Y minus 6 the whole square. Right? Right. Okay. Now I'm going to multiply both the terms by X. So X multiplied by X minus 2 fine, plus X multiplied by IY. So IHY, right? Right. Now I multiply these two terms by the second term. So minus I X minus 2 multiplied by X minus 6, right? Right. Then we are going to multiply this term with IY. So minus I squared value will be minus 1. So minus 1 y multiplied by y minus 6 divided by x squared I the whole squared I squared value will be minus 1 multiplied by y minus 6 the whole square, right? So I'm going to separate the real part and imaginary part. Shall we start doing this? Yes. So who is the real parts here? This guy and this guy. So I can take this directly. X multiplied by x minus 2. Here minus of minus 1 will be plus and y multiplied by y minus 6. Right? Right. Okay. And then who are the imaginary parts? These two are the imaginary parts, right? For both of them, there lies a common element, I. So I'm going to take this out. Plus I. Who remains here? Xy minus x minus 2 multiplied by x minus 6. Right? The entire thing has a denominator y squared minus into minus 1. So plus y minus 6 the whole square. Right? As like that we did in a previous sum, we are going to separate the real and the imaginary part. Okay? So x multiplied by x minus 2 plus y multiplied by y minus 6 divided by x squared plus y minus 6 the whole square plus I xy minus x minus 2 multiplied by x minus 6 divided by x squared plus y minus 6 the whole square. Right? Right. This is the first part of a sum. I will give you 1 more minute so that you can copy this down and we can move to the second part. Right? Right. I will wait for you guys. Okay. Shall I rub? Yes. Okay, fine. So, what is given in the question? So, in the question, it's given as amplitude of z minus 2 divided by z minus 6i equals pi by 2, right? Right. So, what is the formula for amplitude? So, amplitude of z, right? Amplitude of z. Z is a complex number, right? Will be tan inverse of imaginary part divided by real part equals theta, right? What is given in the question? Amplitude of this part. This is z minus 2 divided by z minus 6i equals pi by 2, right? Okay. So here theta will be equal to pi by 2. So we are going to replace amplitude of z minus 2 divided by z minus 6i, right? With this formula, right? Okay. If we substitute this directly here, it will be much more clumsy. So I'm going to replace it little bit. So imaginary part divided by real part equals, this tan inverse go to that side means it becomes tan theta, right? Right. Now we substitute these things here. What we have at imaginary part? The entire tan. Okay. So xy minus x minus 2 multiplied by y minus 6 divided by x squared plus y minus 6 the whole square divided by what we have in a real part, this entire term, right? So x multiplied by x minus 2 plus y multiplied by y minus 6 divided by x squared plus y minus 6 the whole square, right? Right. Equals tan theta. What we have here? Pi by 2. Right. Fine. Okay. Here look at this. The denominator of this one and this one are same. So we can cancel it out. So what will be remaining? xy minus x minus 2 multiplied by y minus 6 divided by x multiplied by x minus 2 plus y multiplied by y minus 6 equals. So what is the value of tan 1 by pi by 2? So tan pi by 2, it's tan 90 degree, which is equals infinity, right? What is infinity? It's 1 divided by 0, right? So I'm going to replace tan 1 by 2, sorry, pi by 2 with 1 by 0. Okay? So 1 by 0. Fine? Now we are going to cross multiply this, right? 0 into anything, 0 equals 1 in this one remains the same. So 1 into this term will be this term. So x multiplied by x minus 2 plus y multiplied by y minus 6. Okay, I can rearrange this and multiply this x and y inside these terms. So x into x, x squared. So x minus 2, x multiplied by minus 2, minus 2x plus y squared minus 6y equals 0. So this is the locus of z. So locus of z is x squared minus 2x plus y squared minus 6y equal to 0. Okay? Fine. So in this sum what they given? They given the amplitude of z minus, so they given that The amplitude of z minus 2 divided by z minus 6i is pi by 2. So we solve this by replacing z equal to x plus iy. Then we substitute the formula for amplitude. That is tan inverse of imaginary part by real part equal to theta. For our convenience, I move this tan inverse to that side. So it will become tan. So tan theta equals imaginary part by real part. From the above solvent equation, we substitute the imaginary part and real part. We cancel the same tans and we simplify it. For tan 90 degree, it will be 1 by 0. We cross multiply it, simplify this. So the final locus is here, right? I give you another 1 more minute for you to copy this down. So I will wait for you and we can move to the next sum. Do any of these guys have doubt in this? If you have doubt, you can ask me now. Okay, guys, I hope you all clear with the sum and you all guys copy this. Shall we move to next sum? Yes. Okay. Shall we move to next sum? Sure. So the next sum is the complex number. The complex number z has argument theta, which is lies between 0 and pi by 2 and satisfying the equation z modulus of z minus 3i equals 0, then prove cot theta minus 6 by z equals I. Right? Right. So what they given? They given that modulus of z minus 3i is 3 and the complex number lies in the first quadrant, right? 0 to 90 degree. Pi by 2 will be 90 degree. So 0 to 90 degree lies in the first quadrant. So we have to prove cot minus 6 by z is equals I. Whatever the question, we have to start from given. What is given? Z minus 3i equals 3. So what we are going to prove here? Cot theta minus 6 by z equals I, right? Right. Okay. Can use solution here. Solution. Shall we start? Right. For solving this, I will take let z equals x plus iy. Right? But what they given here, the given modulus of a complex number. So modulus of z will be square root of x squared plus y squared. That means it will be the square root. There will be a square root. Within the square root, there will be two elements. One is the square of a real part, another one is the square of a imaginary part, right? Right. Is everybody clear with this? Right. So next thing, we know that tan theta equals y by x. In the previous sum, we solved it, right? Tan theta equals imaginary part by real part, right? Who is the imaginary part here? Y. Who is the real part here? X, right? So from this, I can make sure that cot theta. So cot theta is the inverse of tan theta. So cot theta will be x by y, right? Right. So I will give you 1 more minute to copy this down. So we can move to the next part of the solution. I hope you guys copied this down. Shall I rub it and we start the next part? Okay. Okay. From the given, we know that modulus of z minus 3i equals 3. What we take? Z equals x plus y, iy, right? So I'm going to replace this z with x plus iy. So it's where to replace? Here's the z, right? Modulus of z will be replaced by this. X plus iy minus 3i equals 3. Right? So in this both term, I is common. So I will take this thing as common. So x plus I multiplied by y minus 3 modulus will be equal to 0. So for a complex number, modulus will be rewritten as square root of sum of the squares. So for individual elements here, right? Square root of real part square. So who is the real part? X square plus imaginary part square. Who is the imaginary part? Who is the imaginary part? I minus 3. I minus 3 the whole square equals 3. I am going to move this square root here. So it will be there is square. So x square plus y minus 3 the whole square. It will be in the form of m minus b the whole square, which is equal to a square plus b square minus 2ab. Right? So it's like, so who is in the place of a? Y. So y square. Who is in the place of a b? 3. Plus 3 square will be 9 minus 2. Who is a? Y. Who is b? 3. So minus 2 into 3 into y will be minus 6x. So minus 6x here. Square will be moved down to the next part as square. It will be 3 square, right? Okay. So x square plus y square. I'm moving this 9 to this other side. Minus 6y equals. Already 3 squared will be 9. This plus 9 goes there as minus 9. So x squared plus y squared minus 6y equals 0. So I'm going to rewrite it as x squared plus y squared is equals 6y. I'm going to note it as equation 1. Right? Everybody is clear? I'm just take the what is given in a question, modulus of z minus 3i equals 3. We are going to replace z with x plus iy. We are going to separate the real and imaginary part. To replace the modulus, we are going to introduce a square root, and within the square root there will be a sum of individual real and imaginary part squares. So here will be x squared, here will be y minus 3 the whole square, right? And I solved it. We got the equation x squared plus y squared equals 6y. So I will give you another 1 more minute to copy this down. So we can move to the next part. Okay. I hope you guys have copied this down. So I am going to rub this. So what we get, x squared plus y squared equals 6y, right? Right. So what we are given in the question, so we have what we are going to prove here. So we are going to solve cot theta minus 6y equals I. We are going to prove that. So for that I am going to take just cot theta minus 6y, right? Okay. We already find the value for cot theta. What it is? X minus y minus of 6 divided by, what is the value of z? Yes, x plus iy, right? Right. So to eliminate this terms imaginary, right? So I am going to multiply this term alone by its complement, right? So x minus y minus 6 divided by x plus iy multiplied by this term's complement. So x minus iy divided by x minus iy, right? Which equals x minus y minus of 6 multiplied by x minus iy divided by, it is in the form of a plus b multiplied by a minus b, which is equals a squared minus b squared. So who is in the place of a? X. So x squared minus, who is in the place of a b? Y. So I by the whole square, right? So I squared, y squared, right? What is the value of I squared? Is equals to minus 1. So x by y minus 6 multiplied by x minus iy divided by x squared. Minus of minus 1 will be plus y squared, right? So we all know that x squared plus y squared is equal to 6y, right? We are going to substitute this here. X by y minus 6 multiplied by x minus iy divided by 6y. So this cancels this out, right? Right. So x by y minus I minus iy divided by y. So they both have a common denominator. So I take this down, y. So numerator will be x minus I minus of minus iy will be plus iy. So x minus x, 0. So which is equal to iy divided by y. Iy cancel. So final is I. So what we have? We have taken cot theta minus 6 by z, which is equal to I. This is what we are going to prove. Right? We prove this. So we just replace that with x plus iy, and we take the modulus and we substitute the value of cot, and we solve this equation While solving, we use the value. We already got x squared plus y squared equal to 6y here. And we again solve this. We finally got I. So we already proved that cot theta minus 6 by z equals I. Hence proved. Right? Did everyone is clear with this? Did anybody have any doubt? Okay. I will give you 1 more minute so that you can copy this down and we can move to another sum. Any doubts, guys? No. Okay, guys, I hope you all copy this. Shall we move to next sum? Yes. Okay. Shall we start the next sum? Yes. If x equals 6 theta, right? Be clear, it's not cos theta, it's CIS theta, right? 6 theta, then find the value of x power 6 plus 1 by x power 6, right? Right. Solution. Okay. What is given? X equal to 6 theta. Okay, what is 6 theta? What is CIS theta? CIS theta means cos theta plus I sin theta. Right? Right. So, to find this entire term, we have to find x power 6 first. So, x power 6 equals 6 theta power 6. CIS theta power 6. We can substitute cos theta plus n sin theta instead of 6 theta. Sorry, here will be 6. This is equal to cos theta plus I sin theta equals 6. Sorry, power of 6. Okay. So we had a formula like cos theta plus I sin theta power n will be equals to cos n theta plus I sin n theta, right? So in place of n we have 6. So x power 6 equals cos 6 theta plus I sin 6 theta. Clear? Clear. So what will be 1 by x power 6? It will be 1 by cos 6 theta plus I sin 6 theta. Right? Right. If we move a complex number from denominator to numerator, what will happen? Simply the sign of an imaginary element alone changes. So it will become cos 6 theta minus I sin 6 theta. Right? Right. So to find this, we have to find x power 6 and 1 by x power 6. We already did both of this. So I'm going to add two of these, right? X power 6 plus 1 by x power 6 equals cos 6 theta plus I sin 6 theta plus cos 6 theta minus I sin 6 theta, right? Cos 6 theta plus cos 6 theta will equals to 2 cos 6 theta. I sin 6 theta minus I sin 6 theta will be cancelled out, will be equal to 0. So the value of x power 6 plus 1 by x power 6 will be equals to 2 cos 6 theta. Okay? Okay, guys. I will give you 1 more minute to copy this down. So we can move to the next sum. I hope you guys copied this. So I'm going to rub this and solve another one sum now. Right. Next sum is if A, B, C are angles of a triangle. So I can write triangle is short form here. ABC such that x equals cis A, y equals cis B, and z equals cis C. Then we have to find x, y, z. Right? Right. Shall we start? Yes, of course. Solution. What they given? They given that ABC are angles in a triangle ABC. Right? In triangle ABC, okay. If you consider a triangle, what will be the sum of the three angles? It's 180 degree. Right? What are the three angles here? A, B, C. So their sums will be A plus B plus C equals 180 degree. Right? Right. So what we are going to find x, y, z. X, y, z. Right? We are going to multiply these x, y and z values. What we have x? We have x is cis A multiplied by y cis B and multiplied by z, which is cis C. Right? Okay. So what is cis theta? Cis A. Cis A is nothing but cos A plus I sin A. Right? We can also write this as in exponential form as e power IA. Right? Then cis B will be e power IB. Cis C will be e power IC. What we are going to do here, we are going to multiply this. So I am going to multiply this. So e power IA multiplied by e power IB multiplied by e power IC. So base values are same and the power is varying. So we are going to add this all. So e power IA plus IB plus IC. So I is common in both those three of these. So I am going to take I out. So it will be e power I, A plus B plus C. Right? We can rewrite it as is equal to cos A plus B plus C plus I sin A plus B plus C. Right? Right. I solved these things to make you guys understand this. Right? These things is for our understanding. Right? Okay. So, we can write if 6AB3 are a multiplication, we can rewrite it as this of A plus B plus C. Right? Right. What is the value of A plus B plus C? It's 180 degree. It is equal to this 180. Okay, what is this? We can expand it as cos 180 degree plus I sin 180 degree. Is equal to cos 180 degree plus I sine 180 degree. What is cos 180 degree? It's minus 1 plus I. What is sine 180 degree? It's 0. So I multiplied by 0 will be 0. So the final answer is minus 1. So x multiplied by y multiplied by z is equals minus 1. Right? Right. That's it, guys. So I hope you understand this sum. I will give you 1 more minute to copy these things. And today's class is over. We will meet in the next class. Okay, guys? Do you have any queries or questions or doubts? You can ask me now. Thank you.